Now, in this class, we're going to be covering some really, really huge numbers and some really, really, really tiny numbers. I mean, big time tiny, like with about 15 or 20 zeros in front. That's how tiny it is. We start weighing stuff. We start weighing an atom. They're incredibly light. The understatement here. Okay. So we need to know about scientific notation. Scientific notation, the purpose of it is to make awkward numbers less awkward. Basically, we rename the number. We're also going to cover something called significant figures in this unit. Significant figures is a measurement of precision. How precise is the number? Well, for example, when you weigh something in the lab in grams, it's going to be 3 decimal places. At home, I do a lot of cooking. I have a digital scale at home. It goes to one decimal place. Which is more accurate, the one in the lab here or the one in home? One in the lab. That's because it goes to 3 decimal places. It reads milligrams. So significant figures works with all that precision stuff. So you need to learn how to use it though. So our dry lab is on 3 things. First dry lab number 1. It's on scientific notation, significant figures or sig figs or SF, and converting back and forth between those. Okay, so let's start with significant figures. Now, the thing about significant figures is you need to determine with a given number how many significant figures the number has in it. And secondly, you need to know how to use it for something. Like when we do operations in this class, you're going to have to always consider between now and July 30th, significant figures. When you get into 1A, 2A, or 3A, same thing. Sig figs is there. It's never going to go away. Your textbook does a really good job talking about significant figures. Chapter 2. All right. So we're going to make up some rules for significant figures right now. Okay, so the number 1, 2, 3, how many sig figs is that? There's 3 as an example. Okay, anyone else? Let's go on to 100. How many sig figs is that? 1, 0, 0. We have 1, 3. Okay, I want you to look at the difference between these 2 numbers now. 100, 100 point. What's the difference between those 2 numbers? They're not the same number at all.
One has a 0 after the decimal. So it adds another number.
The bottom number's got a decimal point there. Yeah, so hold that thought, okay? So the difference between these 2 numbers is one's got a decimal point, one has no decimal point. Note, okay? So how many sig figs does 100 point have? How many?
Unknown because we don't know what's after the decimal point.
Okay, so in your lab, respond exactly like that. Okay, only it's going to apply to this one, not that one. Okay, Because when you put a decimal point in, it says a lot. With no decimal point, it's to be determined. Okay? All right, so how many sig figs does 100 point? Okay, there's one. Anyone else? 3. Okay. How about 101? 2, 3. Okay, how about 0.0031? Or how many? 2? Much better with the 2. Anything else? Okay, how about the next one down? 0.3105. Or how many? 2. How about 0.3100? Or well, 2. What about scientific notation? 1.02 times 10 squared. 2, 3. Okay. So let's go through these now. This is correct. That's correct. That's correct. That's correct. That's correct. That's correct. That's correct. And that's correct. Now, the tricky part in every one of these, zeros. So there's 3 instances for zeros. They can be in the beginning, middle, and end, and they're all different, whether they count as significant or not. At the beginning, they are never significant. In the middle, they're always significant. And on the end, they're only significant if there's a decimal point present anywhere in the number. Doesn't matter where, anywhere in the number. So this guy here, no decimal point here. So those zeros on the end don't count. That's why there's only 1 sig fig there. Decimal point, that means those zeros count now. 3 sig figs. Okay, zeros in the middle always count. 3 sig figs. Zeros in the beginning never count. That's why there's only 2. Here, we have zeros in the beginning, zeros in the middle. So the ones in the beginning don't count. Ones in the middle do count. So there's 4 sig figs there. Next one down here, 0.3100. Okay, zeros in the front don't count. Zeros in the middle do count. So there's 4 sig figs. 0.3100. Okay, zeros in the beginning don't count. Zeros at the end do count because there's a decimal point. So there's 4. Scientific notation, the only numbers to look at is that one. And that's be 3 sig figs. Oops, I did that wrong. Okay, that makes sense. So your dry lab today and tomorrow, you're going to practice this a lot. And it's just after you practice it a lot, you'll go, yeah.
So what differentiates a 0 in the middle and a 0 at the end? If so a 0 in the middle has to have a number on both sides other than 0.
Yeah, exactly. Exactly. And then one's in the beginning. Because if you redo the zeros in the beginning in scientific notation, those zeros go away anyway. But the zeros at the end, in scientific notation, don't go away. Okay, so my answer to this is, so what? Because just because a number has sig figs in it, if we don't use it, it's useless. So how then do we use numbers? Simple operations. How do we use them? Now, we're not going to be doing a lot of adding and subtracting in here. We're going to mostly be doing multiplication, division, exponentiation. We're doing a lot of that. I want to warn you, Unit 1 is very mathy. There's not a lot of chemistry in it, but you need to know the basics of this math to do Unit 2. Unit 2 is just as mathy, but it's focused on chemistry. Now, what we're learning today is useful in physics, engineering, chemistry. Anytime there's quantitative computations involved, sig figs comes into play. All right, so when we're adding and subtracting, like if we're looking at this number here, okay, we're going to add 1.1 to 0.23. We're looking at the number of decimal places. When you're adding, subtracting, just decimal places. How many are there? Okay, so in this one, there's one place, the bottom one is two places. So whenever we do operations involving significant figures, we always look to the smallest, least precise number of sig figs. So which is smaller, 1 or 2? So your answer is going to have one decimal place. So when we do this addition, it's going to be 1.33. The answer is 1.3. We have to round to the smallest decimal place. Okay? Most of the time, we're not going to be adding subtracting. The only time we're going to be adding subtracting is Unit 2. Unit 2, we're going to be taking the decimal numbers in that periodic table and adding them up. Other than that, we aren't really going to be using, but if you do have to use it, like in Dry Lab 1, you're going to use this rule. Smallest amount of decimal places. All right. So let's look at multiplication division now. Now, you will need a scientific calculator in this class. If you have one already, see if it has something called EE on it. If you've not bought one yet, make sure when you buy one, it has EE on it. So you might want to check out your calculator and look at it and see if it's got it on it. You're going to be using that EE function a lot. Yeah. Okay, it's on the video. Okay, so now when you multiply and divide or do exponentiation, you then look at the whole number for sig figs. Whole number. Doesn't matter decimal places or nothing. It's the whole number. Only when you multiply or divide. So this number has 3 sig figs, that one has 2. So our answer is going to have 2 sig figs. Now my calculator gives me that number. And that is not 2 sig figs. So to round it to 2 sig figs, you go to the third place, one more. That one there. if it's 0 to 4, you drop it. If it's 5 or more, it goes up by 1. So it's 0 to 4, so we drop it. So the answer is 2.6. Now, in some schools and departments, when you have 5 or more, when you have 5, sometimes it goes up, sometimes it goes down, depending on whether it's even or odd. In our school, it always goes up. If it's 5, we round up. For example, if this was going to be 3 sig figs, we go to the 4th place, and it's 5, so that would kick the 2 up to a 3. But again, if you transfer to a school that does this, then you need to look at the number, is it even or odd? And that'll determine whether it goes up or down. But for us, it always goes up. Just wondering. And I don't know if any teachers in this department do that. Most of the time, schools I've worked at, they don't do that. But I know my students that come back and told me rounding depends on the school. And you're right. Okay, so you multiply or divide, you're just looking at the answer is going to be the least amount of sig figs of the operands from the division or multiplication. Okay, does that make sense? Okay, so that's using operations with sig figs. Again, we're going to be doing very little adding and subtracting, mostly multiplying and dividing, like by 99.9%. But you still got to know the adding and subtracting. Okay. On this one here, for example, we're subtracting. So this is two decimal places, 0 places. That means your answer is going to be 0. Past the decimal point. Okay. Let's do another one, this time division. Fraction bar and the division sign are one and the same. So whenever you see the fraction bar, you're dividing. You're dividing the numerator top number by the denominator bottom number. Okay. So how many sig figs is 257? 3. And what about 1.245? 4. So our answer is going to have, now I frequently, almost 100% of the time, will write SF numbers just to help you clarify things. It's optional with you. If you want to put that down, that's fine. If you leave it off, that's fine too. Just make sure your answer is correct if you leave it off. But I always put it on just for clarification. Okay, so our answer is going to be 3 sig figs, right? Okay, so we go to the 4th place. And it's 0 to 4, so we just drop everything. So our answer is 206. 3 sig figs. Okay, does that make sense? And once you're through Dry Lab 1, it'll be solid. Lots of practice. And I have worksheets as well on sig figs under files, unit 1.
Dry Lab,
We do what now?
are we allowed to use our notes on Dry Lab?
Oh, yeah. Dry Labs are open, everything. Internet, notes. Yeah.
So in that case, if you have a scientific calculator, say on our smartphone, we use that instead of having to buy a scientific.
All that stuff is fine except for tests. Okay, all right, so let's now go to scientific notation. Now, the purpose of scientific notation is to make awkward numbers less awkward. Now, every teacher has got their definition of what an awkward number is for their class. This is my definition of awkward number. Is it awkward to you if it is converted to scientific notation? If it's not awkward, don't. All we're doing is renaming the number. We're not changing its value at all. So if you've got a number like that, is that awkward? Yeah, I think it's awkward too. So convert it to scientific notation. Okay, so how do you do that? Scientific notation numbers are in two parts. The first part is a number from 1 to 9.999. 9999, 29 nines there. Okay, and the second part is we're gonna be working in base 10. So it's 10 the sum exponent. Two parts. So let's look at this number over here. Is that number greater than 1 or less than 1?
Less.
Okay, if it's less than 1, your exponent is going to be negative. If it's greater than 1, your exponent is going to be positive. Okay, so question now is we take 456, because you got to convert that to a number from 1 to 9.999. So it makes that 4.56 times 10 to the what? Now that number is less than 1, so our exponent is going to be negative. So the exponent or the decimal point here is between the 4 and the 5. So we're going to go 1, 2, 3, 4, 5, 6. Make sense? Okay, and that number is much easier to work with. Now, I mentioned when you get a calculator, it's very handy. It's not required. It's very handy to have an EE function. So for me to put this number in my calculator, I can do it two ways. I'm going to go So I'm going to go 4.56 EE, change sign because it's negative 6. That is the best way to put it in your calculator if your calculator has EE. If it doesn't have EE, the way you put it in is 4.50, excuse me, parentheses, 4.56 times 10 caret change sign 6, close parentheses. The caret means it's being exponentiated. So the cool thing about EE is it glues the exponent to the number. And that's the purpose of the parentheses. If you don't use parentheses, especially if you're dividing by that number, your answer will be wrong. Now, on a test, there are two parts that most and unit 1 and unit 2. On most problems, there are two parts to the answer. There's the actual number and there's the setup. I divide those setup and answers. I give you more credit for the setup, less credit for the number itself. So 90% for the setup, 10% for the answer. So if you set it up right, but then you didn't put your numbers in your calculator correctly, you're going to get the wrong answer. So say the problem is worth 10 points, you lose 1 point. I give you partial credit for 9 out of 10. So you can do the whole class with no calculator in here, assuming you get all the answers right, and you get a 90% on the test, and you get an A. No calculator. Because your setups, I'll give you full credit for your setups. That's the chemistry part, the setup, not if you can use your calculator incorrectly or correctly. Okay, so it's up to you which one of these you want to use. I highly recommend that one. Students lose less points using EE function. Now, the other one is fine as long as you put parentheses in them. A lot of students forget about the parentheses and they then miss it. And it has to do with the quirk of a calculator. Calculators are incredibly stupid. They don't understand what you meant. It understands only what you put in it. I used to teach robotics, and I used to have my students act out the code for their robot. And as soon as I started doing that, have them do that, they understood how incredibly dumb robots are. It's all in the code. It's like AI, it's all in the code. And this is a little bitty computer. You know, when I was undergraduate, we didn't have calculators. This is like your grandfather talking. We used slide rules. And I always like to show Apollo 13 movie, and there's a whole room of engineers. I mean, I'm talking like 40 or 50 engineers, and they all are using slide rules. And we landed on the moon using slide rules. Slide rules are 3 sig figs, no more than that. We landed on the moon 3 sig figs. And then when I went to graduate school, we could buy a calculator under $500. So this calculator, it's an 84, TI 84, would be about $800 or $900. Now they didn't have anything this powerful in those days. I always bought a Hewlett Packard calculator and used something called reverse Polish logic. And my buddies would always buy the TI calculators. And the TI calculators on the back, it said electronic slide rule. Really funny. Okay, all right. Now, one of the problems you're going to run into on your Dry Lab 1 is they'll give you an incorrect number in scientific notation, ask you to correct it. So this is where this stuff comes in here. Is the number from 1 to 10? If it's not, make it that way. But you can't change the number. You have to modify the exponent. So say we had that. That's an incorrect scientific notation number because the first number is greater than 9.99. So let's correct it. So when we go from 265 to 2.65, what are we doing? Are we multiplying or dividing? Dividing. Dividing by 100. Okay, so if we're dividing by 100, we have to multiply by 100 over here, which is 2 decimal places. And we can't change the value of the number. We just have to name it correctly within the scientific notation parameters. So that's one activity you may be doing this afternoon or tomorrow afternoon. Okay, that's what I wanted to cover today in lecture. And today's lecture will correspond directly to the lab, dry lab 1. Now, are there any questions on this before I close down? Let's see.